Hi, today we're going to start talking about solutions, and I'm going to give you a couple of vocabulary words, and this is just a real short little introduction to everything we're going to be doing with solutions. Before we begin, this represents a solution. Remember from the last lesson that a solution is a homogeneous mixture. It is a mixture because there is two different items or substances present in here. And it is also homogeneous because it is evenly distributed throughout. Now inside a solution, you're gonna have two different components. You're gonna have a solute and a solvent. In this example, this could represent something like sugar water, this could represent something like salt water, but the blue dots here represent the solvent. That is what the other stuff is dissolving in. The solute, typically, in your experience, a solute has been a solid dissolving in a liquid. But it doesn't always have to be a solid in a liquid. It could be a liquid in a liquid. It could be a gas in a liquid. For example, your soda that you drink, carbon dioxide is the solute dissolved in the water, which is the solvent. The carbon dioxide gives it that fizz. Again, so solute is dissolved within the solvent. Now, when you're working on these practice problems, you're going to see a couple of terms. And one of the terms that you have to familiarize yourself with is an electrolyte. An electrolyte, all it means is that it is a compound that conducts electricity in the aqueous phase. Again, an electrolyte conducts electricity in the aqueous phase. The best example of an electrolyte that you know of is sodium chloride. Because when sodium chloride in the solid phase, it's bonded together because we have a positive charge and a negative charge. Once we add this sodium chloride to water, it's going to dissociate or break apart. We're going to have sodium ions, and this is written like this because it's sodium ions in water, and we're going to have chloride ions in water. And what happens is the water, because it is positively charged hydrogens and negatively charged oxygen, it's going to orient itself around the different ions. The positively charged sodium is going to be attracted to the negatively charged oxygen, and the negatively charged chlorine is going to be attracted to the positively charged hydrogen. Now, when you get this into a water solution, or an aqueous solution, recall aqueous means dissolved in water. Your water is going to orient itself like this. Oxygen, two hydrogens. And because there's a lot of sodiums, there's a lot of chlorides, and there's a lot of waters, it's going to transmit an electrical impulse. Because there's these positive and negative charges, that allows these ions to be attracted to the electrons. And when one electron comes in, it's just going to keep moving through the solution. And the movement of electrons is considered electricity. So a flow of electrons is the exact same thing as a flow of electricity. So most of your ionic compounds that we're going to encounter are electrolytes. And that is because they conduct an electric current in the aqueous phase. One other thing that I need to remind you of, or just tell you about, if you look at your reference tables, and you turn to page 6, where it talks about common acids and common bases. Acids and bases, even though we're not going to talk about that until next semester, but acids and bases are also electrolytes. So when you put an acid, like hydrochloric acid, this is just an introduction. You don't have to remember this until later in the year. But when you have an acid or you have a base, they're also going to split apart. And we're going to talk about why they split apart later. Okay, so all you need to know is that if it's in table K or table L, With the exception of ammonia, if it is an acid with an H or a base with an OH, it is going to be an electrolyte. Okay? What I want you to do right now is look at these practice problems, check it out,